Hello and welcome back to another Orange Coast College Mathematics video. In this video we're going to be talking about graphing logarithmic functions. Now when graphing logarithmic functions, there's three really important points that you want to check out. These values are going to be 1 over our base, 1, and our base. So let's go ahead and try graphing log base 2 of x. So we have log base 2 of 1 divided by my base, so 1 divided by 2. And we get to think to ourselves, our base to what power is going to be equal to 1/2? Well, 2 to the negative 1 power is going to be equal to 1/2. And so we can say that our y value is going to be equal to negative 1. So we have ourselves a point, and it's going to be the point 1/2 comma negative 1. Now let's go ahead and try it with 1. So we'll have log base 2 of 1, and we get to think to ourselves, 2 to what power is equal to 1? Well, to the 0 power. So this is equal to 0, and hence we get another point. Now let's do it with our base 2. So we'll have log base 2 of 2, and we get to think to ourselves, 2 to what power is equal to itself? Well, the first power. And so we get that it's equal to 1. This gives us the point 2 comma 1. Now with these 3 points and a general understanding of how logarithmic functions look, you will be able to graph just about any single logarithmic function. Now let's go ahead and look at our domain and find our vertical asymptote. So the domain of the logarithmic function is going to be all positive values. So I cannot include 0, and I can't include anything negative. So it'll be the interval 0 to infinity. Now our vertical asymptote is always going to occur right at that endpoint. And so we can say that our vertical asymptote is going to be the line x equals 0. Now just for fun, let's do one more. If I have log base 2 of 4, what is this going to be equal to? Well, we say 2 to what power is equal to 4? 2 squared is equal to 4. And so we get ourselves another point, 4 comma 2. Now let's go ahead and actually graph these. So first off, we had the point 1/2 comma negative 1. So we'll have a point about there. Then we had the point 1, 0, so over here. And then we had the point 2, 1. And then finally we had the point 4, 2. So right over here. We also know that our vertical asymptote is going to happen at x equals 0. So let's go ahead and draw a dotted line to make sure we don't cross over it. And so now we just get to kind of connect the dots. So this kind of left tail is going to go down to negative infinity. And then this right tail is going to go to positive infinity, but very slowly. It's going to taper off quite a bit. And this is the graph of log base 2 of x. Let's go ahead and check out number 2. Now for number 2, there's 2 parts. There's part A and part B. Let's go ahead and do part A in yellow. And then let's go ahead and do part B in green. So what do we see? We're dealing with a logarithm of base 2, but the only thing that's different is that instead of just x, we have x plus 2. This corresponds to a shift 2 units to the left. Now, since I'm shifting my whole graph 2 units to the left, it's going to change my domain. My domain is then going to become negative 2 to infinity. And then my vertical asymptote is going to become the line x equals negative 2. Now for part B, we still have log base 2 of x. However, this time we're adding 3. This corresponds to a shift of 3 units up. Because I'm shifting the graph up, my domain is actually going to stay the same. So my domain is going to be the interval from 0 to infinity. And my vertical asymptote is actually going to be the same as well. So my vertical asymptote is going to be x equals 0. Let's go ahead and start graphing. For reference, let's go ahead and put those 4 points that we made in our first problem on our graph. So we had 1/2 comma -1, 1, 0, 2, 1, and 4, 2. These are the original points of log base 2 of x, but now we're shifting our graph around. So let's go ahead and put down our vertical asymptote for our part A. We had a vertical asymptote of x equals -2, so let's go ahead and draw the appropriate line. Now for part A, we were shifting everything 2 units to the left, so I can go ahead and take this and just shift it over. So our points are going to become -3/2, -1, -1, 0, 0, 1, and 2, 2. It still follows the same trend where the left tail is going to go down to -infinity, and this right tail is going to go up to +infinity, albeit really slowly. So that's our part A. Let's go ahead and work on part B now. For part B, we were shifting our graph 3 units up, and so our domain and vertical asymptote didn't change from our original function. So let's go ahead and place it down. We have a vertical asymptote at x equals 0. We're then going to take every one of our original points and shift them up 3 units. So we just go 1, 2, 3. And so we're going to end up with 1/2, 2, 1, 3, 2, 4, and 4, 5. Then we just draw our graph. So left end goes down, and then the right end goes up. And with that, we finished our graph for number 2. So let's go ahead and move on to number 3. So for number 3, we're looking at another logarithm of base 2. However, our input looks a little weird. So let's go ahead and manipulate it a little bit. This is the same thing as log base 2 of -x plus 2, or we can write it as log base 2 of negative quantity x minus 2. With this, we can see what's happening to our function. So first off, we have this minus sign right here. This is going to correspond to a flip over the y-axis. Then we also have this x minus 2. This is going to correspond to a shift 2 units to the right. So let's go ahead and determine our domain. Now, we can't have negative numbers inside of our argument, and so we notice that there's a negative sign in here. So I really want this x minus 2 quantity to be negative. And as such, I need x to be smaller than 2. So our domain is going to go from -infinity to +2, not including 2. Our vertical asymptote is going to occur at 2, so x is equal to +2. And now we can start graphing. Let's go ahead and put the original points on for reference. Now we're starting off by flipping our points over the y-axis, and so we can just reflect them. Then from here, we're going to want to shift our points 2 units to the right. And so we're going to get these points over here. Now, if we draw our vertical asymptote in, it matches up very nicely with what we've drawn. This tail going to the right is going to go down to -infinity, and then this tail to the left is going to go to +infinity, but again, very slowly. Now, this is our graph, but we can kind of clean it up a little bit by erasing our intermediary points, and so let's do so. Much better. So let's go ahead and move on to our last problem. Now, for number 4, we're still dealing with a logarithm of base 2, and it's being shifted and reflected. So, first off, we can see that there's this minus sign out in front. This corresponds to a flip over the x-axis. Then we can see there's an x plus 2. This is going to correspond to a shift 2 units to the left. Since we're shifting 2 units to the left, our domain is going to go from -2 to +infinity. And our vertical asymptote is going to be the line x equals -2. With this, let's go ahead and start graphing. As always, let's go ahead and put our original points on for reference. Now, the first thing that we're doing is we're flipping over the x-axis. So, we will get these points right here. Then, we're going to shift these 2 units to the left. And so, we're going to get these points over here. And if we draw our vertical asymptote in, we'll see that this matches up, again, very nicely with the points we've already drawn. This leg to the left will actually go up to positive infinity this time, and the leg going to the right is going to go to negative infinity. Again, very slowly. Now, our graph is done, but we can clean it up a little bit. And so, let's erase our intermediary points. And that looks much better. And with that, we finished our last problem. Well, that's going to do it for this video, and I hope to see you in the next one.